right. Unbelievably, I spelled this wrong on the first thing, but quadrantal angles. There's no first N there, so not really a big deal. But quadrantal angles. All right, quad means 4. I guess that's why I noticed it. Quad means 4. But angles in standard position having their terminal sides along the x-axis or y-axis. So what they're talking about is like this angle right here or this angle right here. Any angle that ends up being on one of the axes, okay? It's the 90-degree angles. Anything that makes like a 90 or a 180 or a 270 or a 360. You can even keep going to 450 and whatever, okay? Those are quadrantals. Quadrantal angles are always going to be a multiple of 90. It's going to always end up on the axis, okay? Those are called quadrantal angles, and you need to know that, okay? You need to know that. That's going to come up. Some of the problems that we do all throughout the semester are going to have to deal with that, and I find the students frequently miss because they don't know what quadrantal means, okay? Likewise, here's the definition: coterminal. Coterminal angles that end in the same place. Okay, so think about this. Think about a 10-degree angle. So if I drew a 10-degree angle, I'd have the initial side and I'd have the terminal side, and then this measure right here is 10 degrees. Okay, that's a 10-degree angle, right? I didn't draw that to scale, but you can imagine that's a 10-degree angle right there. Okay, terminal side, initial side, and measure. But imagine if I drew 370 degrees. Okay, a 370 degrees means I'm going to go all the way around 360 and then 10 more. Okay, right there. That's got an initial side here and a terminal side here, but this measure is now 370 degrees. Now we know that 10 does not equal 370, but if you notice, those two things end up in the same place. It looks like the same alligator. Okay, it looks like the same angle. Those are coterminal because they end up in the same spot. So, one way of finding coterminal angles is just to add 360, however many times you want. Okay, add 360, add 360, add 360. So, a common question looks like this number 5. Find the angle of least possible positive measure coterminal with each angle. Okay. Usually we don't like dealing with numbers like 908. We like numbers in between 0 and 360. Those are the easiest ones to deal with, and so that's what we'll do. Okay? And so the angle of least possible positive measure is basically saying, get me between 0 and 360. And so what you would want to do is say 908 minus 360. Oops. Let's try that again. 908 minus 360. That's too big, so let's subtract 360 again. We're shooting for something in between 0 and 360. And once we get there, we subtract a couple of times. We subtract 360 a couple of times. In fact, we subtracted it twice, and we ended up with 188. If you drew a picture of 188, what you would end up with is an angle that ends up in the same place as 908, the coterminal. So then if I do negative 75, in order to find the least possible positive measure that's coterminal with negative 75, this time I'm going to add 360. All I'm trying to do is get back in between 0 and 360. That's what I'm trying to do. So negative 75 plus 360, 285. If you drew that angle, it'd be in the exact same place as negative 75. It would end in the same place. Don't forget your degrees. Negative 800 I'm going to add 360. I need to add it again. I'm still negative, so I'm going to add it a third time. I end up adding it 3 times. Add 360 3 times, I get 280. So plus 360 plus 360 plus 360. It's not really important that we show this work. We just have to know how to get there. The angle with least possible positive measure that's coterminal with negative 800 is 280. And so again, what that means is if you drew a picture of 280, that would end up in the exact same place as negative 800. And so everything about them would behave in the same way because we're essentially talking about the same picture. Here's a question that causes a lot of problems. This will be a test question, and people will miss it. And so I'll ask it on another test, and people will miss it again. And you'll end up seeing this same question on 3 or 4 different quizzes and tests because people keep missing it, okay? All you're doing is an expression, to me, signifies there's going to be algebra in there, okay? So in order to get coterminal, you're going to have to add 360 X number of times. So literally all you have to do is say 60 plus 360 in, or you could say X, it doesn't really matter, but that's it. That is an expression that's going to generate every angle that's coterminal with 60, okay? Think about it. If I plug in 1, that's going to say 60 plus 360. If I plug in 2, that's going to say 60 plus 360 twice. And that's just going to take me around to the same spot, around to the same spot, around to the same spot. So then the other one, all you're doing is saying 200 plus 360 in. Now you could argue, well, can I say minus 360 in? Yeah, I suppose that would work. All you're trying to do is just generate something that's 360 degrees away. And that's it. Number 6 is a conversion problem. It says CD players always spin at the same speed. Suppose a CD player makes 480 revolutions per minute. Through how many degrees will a point on the edge of a CD move in 2 seconds? Question mark. Okay. So, what? CDs are a circle, and you've got some point on the edge. Okay. And so it says we start with 480 revolutions per minute. Use your units, okay? People who don't write down their units don't understand, okay? Generally, they don't do it right because they don't understand what they're doing, okay? The numbers seem to come from nowhere when you're not looking at the units. But we start with 480 revolutions per minute. And we know we need to convert it into degrees, okay? So let's think about how to convert it to degrees. Well, if you think about 1 revolution, how many degrees is that? 360. There's your conversion right there. I know 1 revolution is equal to 360 degrees. So I can use that as a conversion factor, okay? I would put the revs on the bottom because I want that to cancel out. 1 revolution is 360 degrees. In these kind of problems, it's all about canceling your units. So now, looking at my units, I have degrees, but it's degrees per minute. And I don't want degrees per minute because they're talking about seconds here. Okay? So I need a conversion from minutes to seconds. And we know that 1 minute equals 60 seconds, right? So there's your conversion. 1 minute is equal to 60 seconds. So which one goes on top? Minutes or seconds? Minutes, because you want it to cancel out. Okay? I put minutes on the top because I'm going to end up trying to cancel out those minutes right there. Okay? So now I've got degrees over seconds. And that's pretty good, except for the fact that it asks me something about how many degrees in 2 seconds. Okay, so let's just multiply by 2 seconds, and that's going to answer the question. That's going to leave me with the seconds cancel. That's going to leave me with just degrees, And that's what I want. Through how many degrees? Look at my units. That's all that's left. So in order to type this in a calculator, how I would do it is this. Any number that's on top is going to be multiplied. Any number that's on bottom is going to be divided. Okay? So you don't have to do this by hand. You can type it all in on the calculator at the same time. Just understand that any number on the bottom is going to be divided. So I can say 480. That's divided by 1 minute. You don't have to divide by 1. You don't have to do anything with the 1. So the next thing I'm going to do is times 360. And again, that's divided by 1 there, but I don't need to divide by 1 because that's easy. Okay. And then same thing right here, times 1. I don't need to multiply by 1. But the next thing I'm going to do is divide by 60 because that's on the bottom. Okay. And then I'm going to multiply by 2 because that's on the top. Okay. I'm left with 5,760 degrees. Which is your answer. Through how many degrees will the point on the edge of that CD move in 2 seconds? 5,760.